Hello, and welcome to the Research Methods course. This is Professor Saltanat Liebert at VCU. Today's topic is sampling and generalizability. This slide places sampling in the research process. I have talked about the research process in my earlier lecture, but here's a brief recap to remind you. We first start the research process with a definition of a research topic. We then specify the research questions. The next step is conceptualization, specifying what we mean by a term that is the focus of our study. We then operationalize key variables, defining how each concept is measured and observed. The next step is selecting the methodology. It could be quantitative, qualitative, or mixed method, which uses both quantitative and qualitative methods. We'll talk about each of these methods in the coming lectures. The next step is that we need to decide which sampling method to use. This is what I'll talk about in this lecture. The step after that is data collection, which is followed by analysis of the data that was collected. The next step in the research process is the write-up of the findings. And the final step is the dissemination of the research findings. Sampling is the process of selecting individuals for a research project. In order for a researcher to be able to generalize the study findings to the whole population of interest, the researcher needs to select a subset or a sample of this population. Sample selection for quantitative and qualitative studies tends to be different. Sampling frame is a list of all individuals in the population of interest. In this image, population of interest is the green shape. Sampling frame is the orange shape. You would recruit individuals from the sampling frame to end up with your sample. Sample consists of individuals who agreed to participate in your study. A census is when we study the entire population, which means there is no sample, as all of the individuals in the population participate in the study. As you can imagine, surveying the entire population is time-consuming and expensive, which is why the census of the entire population of the US is conducted only once every 10 years. Census can also refer to smaller groups than the entire population of a country. For example, we can conduct a census of the VCU student population by surveying every single student enrolled at our university. Sampling should be done in quantitative and qualitative research, but the sampling types usually vary between these two types of research. Sampling could be probability sampling and non-probability sampling. Probability sampling is the preferred sampling method in social sciences. It utilizes random selection of study participants. An example of random selection is a lottery. Another example is flipping a coin. Probability sampling is not always feasible in social sciences, especially if we are trying to reach population that is hard to recruit. For example, if I want to study the impact of COVID-19 on the undocumented immigrants, it is unlikely that I could use probability sampling. This is because there is no list of all undocumented immigrants that I could use as a sampling frame. In these types of situations, I would use non-probability sampling for my study. An example of non-probability sampling is a snowball sampling. In the example I mentioned earlier, I would recruit 1 or 2 undocumented immigrants to participate in my study, and then I would ask them to refer me to their peers who have a similar immigration status. When it comes to probability sampling, there are several random sampling techniques. The old school method is picking names out of a hat. You can use a random number generator, a system that generates random numbers which would meet the requirements of probability sampling. The third technique is systematic random sampling. Let's say I want to survey a sample of VCU students, and I want the results to be generalizable to the entire VCU student body. Sample size, or a number of students in my sample, has to be 380 participants. for the sample to be generalizable to the entire body of VCU students. I got the number of 380 using a sample size calculator, which I will show you in a few minutes. In order for the study findings to be generalizable to the entire population of VCU students, my sample would need to be selected randomly. To do this, I would need to determine a sampling interval, which is a distance between measurements that are taken or data that's collected. In the example of VCU students, my sampling interval is 81, which means I would select every 81st student to participate in the study. Sampling interval is calculated by dividing the entire population of interest, which is 31,000 VCU students, by the sample size that I hope to obtain. This calculation results in a sampling interval of 81. So to carry out systematic random sampling, I would need to calculate my sampling interval, which is 81. Then I would need to randomly select a number within the sampling interval, so any number from 1 to 81. And then, from that starting point, I would select every 81st student for participation in my study. And if the randomly selected number within this sampling interval turned out to be 4, for example, I would select the 4th student on the list, then 85th student, then 169th student, and so on. The list of all VCU students is my sampling frame. Stratified random sampling is a method of sampling that involves dividing a population into smaller groups called strata. The groups or strata are organized based on the shared characteristics or attributes of the members of the group. Cluster sampling is a technique in which clusters of participants that represent the population are identified and included in the sample. Cluster sampling involves identification of cluster of participants that are representative of the population and their inclusion in the sample group. The image on the slide shows the process for cluster sampling to end up with a nationally representative sample of K through 12 students. The first step would be to randomly select states. The second step is to randomly select cities, towns, and counties within those states. The third step would be to randomly select schools within those counties, cities, and towns. And the last step is to randomly select students within each school. This is a more efficient process than sampling all of the schools in the country. It is as valid for research purposes because there is random selection at several phases of the study. We typically talk about sampling in the context of quantitative research, but sampling protocols need to be observed in qualitative research as well. Probability sampling is preferred, but there are circumstances when non-probability sampling is the only possible way to recruit study participants. This is often the case with difficult-to-reach populations, such as drug users or undocumented immigrants. One example of non-probability sampling is purposive sampling. Individuals in purposive sampling are selected because of their characteristics that are not common in the general population. For example, a colleague and I conducted a study a few years ago on how undocumented immigrants access healthcare. We used purposive sampling, recruiting study participants who did not have health insurance and were unauthorized immigrants. Probability sampling in that case would not have been feasible. Snowball sampling is when you recruit future study participants through current study participants. As a researcher, you could use more than one of these sampling techniques. For example, in the study that I just mentioned, the one that examined how uninsured and undocumented immigrants access healthcare, we used both purposive and snowball sampling to recruit study participants. The next non-probability sampling technique is convenience sampling, which is also referred to as availability sampling. Study participants in convenience sampling are selected because they're easy to find. As you can imagine, convenience sampling is not considered to be a robust sampling technique, but it is appropriate in some cases. The final non-probability sampling technique is quota sampling. As the name suggests, in this sampling technique, coders are set to make sure that sample is similar in its composition to the population of interest. An important issue in qualitative research is the appropriate sample size. The norm for qualitative interviews is that researchers should keep conducting interviews until the point of data saturation is reached. Data saturation happens when new information is no longer gathered in the interviews and when the themes emerging from the interviews become repetitive. There is no specific standard on how many interviews are deemed to be sufficient. Some scholars argue that 12 interviews is a minimum. In peer-reviewed journals, for example, more than 25 interviews is typical, and I have seen studies in peer-reviewed journals that report on qualitative interviews that have conducted about or more than 100 qualitative interviews. Sampling in quantitative research is more straightforward in that there are specific standards. So you would calculate the appropriate sample size using software or specific websites. SPSS, for example, the statistical data analysis software that we use here at VCU, has a built-in sample size calculator, as do surveys such as Qualtrics and SurveyMonkey. Your sample size will depend on the population to which you are trying to generalize. If you are conducting a survey, you want the results to be generalizable to the population of the US. The sample size you would need to get is 1,068 randomly selected individuals. On this slide here, I use the sample size calculator built into SurveyMonkey, the survey platform. In the population size box, I plugged in 255 million, the current US population. I selected a confidence interval of 95%, which is the norm in social sciences, and the sample size that the program calculated for me is 1,068 individuals. In social science research, you often hear the term generalizability. There is sample generalizability, which refers to the notion of whether findings from a sample of the population can be generalized to the entire population of interest. Then there is cross-population generalizability, which refers to whether findings from the study of one population can be generalized to another. Two terms that are important in the context of sampling and generalizability are sampling error and margin of error. Sampling error is the difference between the characteristics of a sample and the characteristics of the population from which the sample was selected. The goal of the researchers is to minimize sampling errors. Only a full census can completely eliminate sampling errors. Margin of error is a statistic that expresses a sampling error. In the sample size calculator I showed you earlier, there is a statistic expressing a sampling error. Given the sample size this program generated, the margin of error will be plus or minus 3%, meaning that the findings will range within this margin of error. Let's say I surveyed 1,068 individuals and found that 70% would be willing to donate 1% of their income to charity. The margin of error means that the real number ranges from 67% to 73%. This is the end of the lecture on sampling and generalizability. Thank you for watching and take care.